Okay, welcome back, folks. We are checking the page 352 assignment, and here we go. There's the first problem, number 2. We're going to use, of course, the quadratic formula, which is x equals inverse b plus or minus the square root of b squared minus 4ac all over 2a. Do you know what the quadratic formula does for us? Oh yeah, it gives us answers, but there's something really special about it. It eliminates the need for ever completing the square. Real people in architecture, engineering, electronics, physics, real people don't complete the square. They use the quadratic formula. Because here's the cool thing, think about it. How did we get the quadratic formula? By completing the square. So the quadratic formula has completing the square built into it. It's a cool concept there. So why do I want you to be able to complete the square? Because I want you to know where this came from. And it's a great mental exercise to be able to complete the square. In fact, there's going to come a time later on, later this year and certainly next year, when there are some things you're going to have to do that require completing the square for a different purpose. So we'll get to that some other time. So for now, let's just continue. So x equals what? It equals the inverse of b. The inverse of negative 6, that's positive 6. Plus or minus the square root of b squared, that's negative 6 squared is 36. This guy here, of course, will always be positive. Minus 4 times 1, that's a, times c, that's negative 4. 4 times 1 times negative 4. 4 times 1 times negative 4 is negative 16. But we're subtracting the negative 16. So that means we're actually going to add 16. And we're dividing by 2 times a. A is 1. So we're dividing by 2. And we simplify, and what happens? We get 6 plus or minus the square root of 52, all divided by 2. Now, yes, you are expected to simplify radicals. Sorry. Well, 52 happens to be 13 times 4. So 4 times 13, the 4 goes pa-ching, pops out. That gives us 6 plus or minus 2 square root of 13 all over 2. And yes, I expect you to reduce fractions. These can both be divided by 2, therefore we do it. And what do we get? We get 3 plus or minus cancels, square root of 13. There it is. And we move on to number 4. By the way, the fact that the results are irrational tells us that the original problem could not have been factored. More on that as we go. All right, let's take a look at this guy. Oh, by the way, I can see immediately this can be factored. Because it can be factored, I know my solutions will be rational. There will be no radicals involved because I could factor this very easily. But on this assignment, you were to use only the quadratic formula. So we have inverse b, x equals inverse b. Inverse b, that's going to be a positive 2, plus or minus the square root of negative 2 squared, that's 4, minus 4 times 1 times negative 15. Negative 15 becomes plus 60. Oh, look what they're doing there. Nice numbers. All divided by 2 times a, which is 2. And from that, we have 2 plus or minus, board glitch, move down here, equals 2 plus or minus square root of 64, which is 8, over 2, which gives us 2 answers. 2 plus 8 divided by 2. Or 2 minus 8 divided by 2. And we get our 2 answers, and checking because I'm prone to making careless mistakes, especially when I'm rushing, we have 5 and negative 3. Yep, correct. Ta-da. And we will move on to number 6. Now, number 6, there's a bit of an issue. You can't use the quadratic formula until you have the equation in standard form. So, we have to get that 30 over there on the left side. We have y squared minus 7y. But I thought we had to get the 30 on the right side and get it out of there. That was when we were completing the square. We're not completing the square now. We have to start with standard form. Yes, if we were completing the square, we would leave that 30 right where it is. But we're not completing the square. We must have standard form. So, moving on, we have x is inverse b, that'll be a positive 7, plus or minus the square root of 7 squared, 49, minus 4 times a times c. That's minus 120, which becomes minus a minus 120, which becomes plus 120. Ooh, nice numbers. What do you mean? Oh, you'll see in a moment if you didn't already see. All over 2 times 1, and that gives us 7 plus or minus the square root of 169. Haha! What's so special about 169? Well, we know the square root of 169 is 13. So we have 7 plus or minus 13 divided by 2. That's 7 plus 13 divided by 2. That's 10. And 7 minus 13 divided by 2 is negative 3. And checking our answers, yep, 10 and negative 3. And the fact that we get these nice, neat, rational numbers tells us we could have factored the original problem. This is factorable. But let's move on. Number 8. Oh, look at this. I've got the formula written there for you already. By the way, don't worry about the fact that these are m's. They act just like x's. It doesn't matter. It doesn't matter. I'm sure you realized that. So inverse b, that'll be a negative 3. There's b. And b squared, being 3 squared. 4 times a, that's 5, times c, that's, watch out, negative 2, over 2 times 5. And now we just do the arithmetic. I mean, it's practically done. That is our solution. We just need to do the math. So we have negative 3 plus or minus square root of 9. Negative times negative becoming positive. That's 20, that's 40. Ooh, look at these nice numbers. Divided by 10. And again, why do I say nice numbers? Because we know the square root of 49, yes. So we now have negative 3 plus or minus square root of 49 over 10, which gives us final results of 2/5 and negative 1. Again, rational solutions tells me I could have factored the original equation. In fact, factoring is usually the easier way to do it. Then why do we need the quadratic? Oh yeah, we need the quadratic formula for those cases where you can't factor it. Right, you remembered. Number 10. Now there's a trick we can use here that's going to make our life much easier. First of all, this is not standard form. Sorry. We have to get standard form first. So we have 3u squared minus 18u plus 6 equals 0. Now, what's the trick we can use here? Yes, you're right. Divide everything by 3. Good thinking, yes. That'll make life easier. We don't have to do something nasty like squaring 18 and stuff like that. Makes life a lot easier. So dividing everything by 3, we now have u squared minus 6u plus 2 equals 0. That's better. That's much better. Now, so I don't get confused about what numbers I'm using, I'm going to erase this. It's gone. And now we'll simply plug these guys into that. So we have inverse b, that's going to be a positive 6, plus or minus 6 squared, minus 4 times 1 times 2, that's minus 8. 4 times 1 times 2, I'll leave that way, I can't erase that. And all over 2 times a, which is 2 times 1. And we're off. Simplifying, we have 6 plus or minus the square root of 36 minus 8 being 28 all over 2. Simplifying that, yes, we do have to simplify radicals. That's still expected. Just like in 3rd grade, you were expected to always reduce fractions. Likewise, now we're always expected to simplify radicals, like it or not. 7 times 4, the 4 pops out, pa-ching! we have 6 plus or minus 2 square root of 7 over 2. Okay, I'm going to get this out of the way. Thank you. And then divide both of these guys by 2, and we get 3 plus or minus square root of 7, and there it is. Ta-da! Gee whiz, Mr. Pierre, these are easy. Yeah, once you get used to it, they really are. All right, and this guy, hey, what is A? A is 1. B is also 1. Interesting. And C is 2. And nope, you're not going to be able to factor that thing. You can't find numbers that multiply to give 2 and add to give 1. No, it's not factorable. Therefore, we're going to get irrational answers guaranteed. Let's dive in. We have x equals inverse b. That's going to be negative, oh, board glitch there. Negative 1 plus or minus square root of b squared, that's 1. Minus 4 times 1 times 2, that's 4 times 4 times 1, I'm rushing so much I'm losing track of what I'm doing, divided by 2 times 1, which gives us, provided I'm not making some careless mistake in my haste here, square root of negative 7. Ooh, okay. Well, can't leave it like that. Can't leave it like that. You cannot leave a negative under the radical. We change it into correct imaginary number form. So we have negative 1 plus or minus I square root of 7 over 2. And assuming I made no mistakes, yep, there it is. It's correct. Nice that I have the answers down here so we can check ourselves. Number 14. Ah, yes, the famous number 14. Okay, and this guy, you look at this and say, what in the world is that? It doesn't even look like a quadratic equation. Well, how about if we do something we learned back in an old chapter? Let's clear the denominators. Let's multiply both sides of this equation by the LCD, x squared. Here it is, multiplying this side by x squared and multiplying this side by x squared. So what happens when we do that? X squared times 1 plus, here the x squareds cancel, equals, here that x cancels one of those x's, so we have 2x. And now it's looking better. Now it's looking like something we can work with. Let's get everything on the left side. X squared, subtract 2x, bring down the plus 5, equals 0. Plug it into the quadratic formula. I'm not going to go through the trouble of and time of figuring all that out, but we end up with 1 plus 2i, which tells me that it must have started off as 2 plus or minus 4i over 2, but the 2's canceled out there, and we get 1 plus or minus 2i. All right, let's go on. Hopefully we're nearing the end here. Oh, wow, we still got a ways to go, don't we? 16, tell you what, we're good at this now, right? Right. I'm just going to give you the answers. Number 16, there it is, 2 plus or minus I. It must have started off life as 4 plus or minus 2i over 2, and you reduce the fractions and you get 2 plus or minus I. Yep, yep. You don't need to see me do these anymore. Subtract 6x. X squared minus 6x. You've got to have standard form first. You've got to have this 0 over here first. And then plug the stuff in. Anything fancy happen? It's just ordinary. You know, it's hard to make these hard. They always work out the same way. And looking at the a value there tells me that this must have started off as 6 plus or minus 4i over 2, which reduces to 3 plus or minus 2i. Next, number 20. Okay, don't worry about the fact that it's h. H acts just like x. So putting this in standard form, subtract 6h. And then we'll have h equals what? Well, again, I don't see anything fancy about this. It's just going to be pretty straightforward, isn't it? Yep. We get 3 plus or minus square root of 5. It must have started off as 6 plus or minus, what was it again? 5, square root of 5. 2 square root of 5 divided by 2 times a, which was 2, and that reduces to 3 plus or minus square root of 5. Mr. Peer, we want to see all the details. Sorry, we're out of time for details. Oh, look at this. What do we do with that thing? That doesn't look like a quadratic. Ah, but it is. We need to, yeah, I hear you. We need to multiply this out. Distributive property. So we have 4x plus x squared minus 3x. Let's put it in the natural order so we don't get confused. X squared plus 4x minus, wait a minute, what about, oh, well that's interesting. We have 4x plus negative 3x. These guys become just plain x. X squared plus x equals 0. Now that's unusual. What's c? A is 1, b is 1, c is 0. Hey, remember, this is one of those really easy ones. Without the quadratic formula, we could factor out the x. Don't tell anybody. We'd have x plus 1, and therefore the answer should be 0 and negative 1. Yep. But if you put it in standard form, as we've done here, recognizing that c is 0, and plug all this stuff into the quadratic formula, just like always. A is 1, b is 1, c is 0. Plug it in. You will indeed get 0 and negative 1 as your answers. Nice. Interesting little problem there. Yep, you had to multiply this out to get standard form. And don't let it worry you if c disappears. In this case, there was no c value. And the last one, yes, 24. This one is a little bit different because I think it's the first time on the entire assignment, maybe not, I don't remember now, where a was not 1. A is 3 this time. So we have inverse b, that's negative 1, plus or minus square root of b squared, that's 1, minus 4 times 3 times 2, that's 4 times 6, that's 24, over 2 times a, which is this time for a change 6. Yeah, I think maybe we did see one like that before. I don't remember now. So we have negative 1 plus or minus square root of negative 23 over 6. You know, there's a nice thing about radicals that can't be simplified. The nice thing about them is you don't have to simplify them. Negative 1 plus or minus I square root of 23 over 6, and we are done. And yep, got it. Okay, no careless mistakes. I'm on a roll here. Good. All right, now, at this point, we can pause the video for a moment as you guys mark your papers carefully. There were, 12 possible problems. With 12 possible, you can miss 3 and still have a 4. You can miss 6 and still have a 3. You can miss 9, I hope you didn't, and still have a 2. You can miss them all and still have a 1. Mark your papers quickly and pass them up. Be sure your name's on the paper. Be sure your name's on the paper. Okay. All right, so I pause for a moment while you pass up your papers. Thank you. We can pause the video if necessary while you continue to pass up your papers. And we move on to the new topic. Yay! We were so excited about doing a new topic. Yes, I'm sure you were. All right. Now, the new topic is actually quite short and quite simple. Good thing, because I don't know how long this video is so far, but let me tell you what, I'm going to come around here and see what the screen says. Oh, wow. I've only used 19 minutes so far. We've got plenty of time. I can relax a little bit. But here we go. New topic. I'm on page 354. This is section 8.4. 8.4. The topic is something called the discriminant. The discriminant. The discriminant allows us to discriminate. To discriminate, to see the differences between things, to decide what something is going to be like. To discriminate, we use the discriminant. What in the world is the discriminant? All right, well, x equals inverse b. Okay, you tell me, inverse b, keep going. Yep. Yep. Yes, I heard that. Of course, I think you're just thinking it, so I'm hearing your thoughts. Over what? Yep, I heard that thinking. Okay, there's your quadratic formula. As we've observed before, I think we've observed before, if you look just at b squared minus 4ac, if this turns out to be negative, what kind of answers are you going to get? If you got the square root of a negative, then you're going to get imaginary answers. How many? 2. So if b squared minus 4ac is negative, instead of writing the word negative, I'm going to say less than 0. If it's negative, then you get 2 imaginary answers. Will it always be 2? Yes, it'll always be 2, because it'll always be plus or minus. All right, so what if, hey, suppose we haven't even seen one like this yet. Interesting, we haven't seen one. What if b squared minus 4a turns out to be 0? Can that ever happen? Yes, that can happen. What if b squared minus 4ac actually turns out to be 0? And I'm sorry we haven't seen one like that, but you will. What if b squared minus 4ac is 0? Well, if it's 0, this whole thing just goes away because the square root of 0 is 0. So it's plus or minus nothing. So you're going to get only one answer, and it will be inverse b over 2a. Because the plus or minus stuff's gone. There's no radical, there's no plus or minus, it's all gone. Because we had the square root of 0. So, in this case, then what do we get? We get one rational. Instead of using the word answers, I'm going to switch that to the word roots, the fancier mathematical algebra word for it. Here we get one rational root. Now what if, can I put this back? Inverse b plus or minus the square root of b squared minus 4ac all over 2a. All right. What if b squared minus 4ac turns out to be positive? What if it is more than 0? What if b squared minus 4ac, how do we say positive in algebraic terms? Well, that would be greater than 0. Positive. If it's positive, then what happens? Well, if this is positive, you're going to be stuck with the plus or minus, so you're going to get how many roots? Yeah, the positive and the negative. You're going to get 2. Yes. So we're going to get 2, and what kind will they be? Well, if this is positive, they certainly are not going to be imaginary. They will be real. You're going to get 2 real roots. Now, furthermore, and I don't think the book authors here made a big deal of this part, but it also happens that if b squared minus 4ac is a perfect square, such as, for instance, 25, then the radical is going to disappear, and you're not just going to have real solutions, you're going to have real rational solutions if the radical disappears. The book doesn't point that out, though. I don't know why. I kind of wish they did, but they didn't. All right, now, there's another little detail. We'll ignore that one for now. Okay. Because, let's put this back. Because this thing enables me to decide in advance, if I need to, how many answers I'm going to get and what kind of answers I'm going to get. That is called the, yes, backing up to that word I started with. That thing right there is called the discriminant. B squared minus 4ac is called the discriminant. So, on the assignment and on the test, you will be asked to use the discriminant b squared minus 4ac to determine the nature of the solutions. What do you mean by nature? Oh, by nature of the solutions we mean how many and what kind. Will you have 2 or will you have 1? Will they be imaginary or real? Will they be rational? And if this happens to be 0. And that is that. Oh, yep, okay, yeah. The book also for some reason does not mention the word rational here. They just say, if the discriminant is 0, then you get 1 root. Well, fine. I like mentioning that it's 1 rational root. Undeniably true. So there you have the purpose of the discriminant. Let's see, anything else we need to know about that? On the assignment, when you're asked to use the discriminant to determine the nature of the solutions, I expect to see clearly indicated on your paper that you knew what is meant by the discriminant. I need to see the result of b squared minus 4ac clearly on your paper. I expect to not see the entire quadratic equation, or quadratic formula, I should say. I don't want to see the quadratic formula. I want to see that you understood what the question was. I want to see only that. So if we were to back up, say to one of these simple looking ones that's already set up for us, how about that one? What is the discriminant? B squared minus 4ac. So the discriminant is 16 minus 4 times 1 times 5 minus 20. So the discriminant is negative 4. Why do I not remember this one? Okay, yeah, that's right. I think that's right. So the discriminant is negative. Because the discriminant is negative, that means we're going to get what? We're going to get 2 imaginary roots. There, you have done it. I expect to see this clearly indicated on your paper that you knew what was meant by the discriminant. I do not want to see you use the entire quadratic formula to get the final answers, because that doesn't prove that you understand anything, except for the quadratic formula. All right, pretty clear? Good. So when we check this paper tomorrow, I'll be checking to see that you have the discriminant numbers clearly indicated along with your conclusions of how many and what kind of answers you would get. By the way, don't get confused. This is not a solution of the equation. This simply tells you what kind of and how many solutions you're going to get. This says you're going to get 2 imaginary solutions. This is not a solution. All right, that's it. Your assignment. Let's see. Your assignment is the following. Okay. Page 357, numbers 2 through 14, even, due tomorrow. And that's it. Hope you enjoyed the video. Mister, we never enjoy algebra. Oh, come on. Algebra's fun. All right, see you later. Bye.